Question number 7. Propane dioic acid contains 2 carboxylic acid groups. So propane has got 3 carbons in it. Ane means it's got single bonds. Dioic, di means 2 carboxylic acid, 2 oic acid groups. It's a solid organic, it's solid and is soluble in water. Draw the skeletal form of the propane dioic acid. So I've got to have 3 carbons. Remember that a skeletal formula doesn't show any carbons. There are no carbons there. The carbons are just at the corners, so it ends up as a zigzag line here to show carbons at each of the corners. You don't show any carbons, and you don't show any hydrogens bonded to carbons either. So I do show the double bond to oxygens, and I do show the OHs also bonded. So I've got a dioic acid, a C double bond OOH on carbon number 1, and I've got a C double bond OH on carbon number 3. Remember, carboxylic acid groups always go at the end of the chain. Something like a nitrile will always go at the end of a chain, and N at the end of the chain, and also something like an aldehyde will also go at the end of the chain. So they've got to go on carbons number 1 and 3, and in the middle there I'm not showing the carbon on the middle of the chain, nor the C to H bonds on the middle. Propane dioic acid. Describe how you prepare 250 centimeters cubed of aqueous standard solution of propane dioic acid contained in accurately measured mass of acid. It doesn't tell you what the mass of acid it is that you've got to use, but you've got to know what that is, what's needed. Include essential practical details in your answer for 6 marks. Okay, so first of all, it's a solid. So to measure the mass accurately, you're going to need a weighing bottle. That's a small flask into which you can weigh things out in a digital balance, and you put the weighing bottle onto the digital balance and press the tare button. The tare means that it ignores the weight of the bottle, so it'll go back to 0. It will 0 the balance and ignore the weight of the bottle. That's going to increase your accuracy, because it's going to mean that you're only going to have to produce one reading rather than 2 readings and subtract. So it's going to allow you to increase the accuracy. Percentage error on your in your experiment will be reduced, will be lowered. So press the tare button, 0 it, imagines that the weighing bottle is not there. Then you're going to get a spatula and add the propane dioic acid. Remember, it's a solid, so that's why you can use the spatula, into the weighing bottle until the desired mass is reached, until you've got the mass of the propane dioic acid that you want. It doesn't tell you what it is, but you need to know what it is. You'll know what it is in your experiment. We've been given that in the instructions. Add the contents of the weighing bottle into the volumetric flask. So you can add it into a volumetric flask. Remember, a volumetric flask is just a flask with a mark on it, which will measure 250 centimeters cubed. And then, importantly, here for a mark, you've got to rinse the weighing bottle with distilled water, because when you tip the solid from the weighing bottle into the volumetric flask, there's bound to be still some remaining. Some of the solid will still be remaining. They'll be stuck to the sides of the weighing bottle or stuck in the bottom of the weighing bottle. So you rinse the weighing bottle with distilled water and pour that into the volumetric flask. Now in the volumetric flask, you've got your solid propane dioic acid and a small amount of water that you've been used to rinse the weighing bottle in there as well. And you then make up to the mark, up to the 250 centimeters cubed mark on the volumetric flask by adding further distilled water. Okay, in the next part of the equation then, you've been given a concentration. You've got a concentration here, 0.005, and you've got to work out the number of moles. So you've been given 250 centimeters cubed, which is in decimeter cubed, if you divide by 1,000 is 0.25. You've got to work out the number of moles of propane dioic acid that you need to use. So it's 0.005 multiplied by 0.25 is 0.00125. That's number of moles. And therefore you've got the MR as well. You've got the MR of the propane dioic acid. So now you've got moles. Moles is mass divided by MR. So 0.00125 is mass divided by 104. Multiply the two together, and it tells you how much propane dioic acid you've got to add, which is 0.13 grams.